Guys, in this reach, yes, hello guys, hello everybody. So in this session today, we are going to introduce something which is very new topic in machine learning. So like here are some topic that is related to yes, GD and GD. Uh, so we can start discussing one by one each and every topic. So let's discuss the first point. So uh, and if you have some doubt, you can ask in the comment section or you can message me directly. So we can review your doubts as well in the later on as well. So on the later on the next basis, we can discuss your doubts as well. So let's start the doubt session later on. So the point is that what is the point we have? The first point is that what is the difference between stochastic gradient and gradient descent? So this is the first question in front of us. So this is the first question in front of us, and I believe that gradient descent is nothing but the y equal to mx plus c. That is the slope of the equation, and we are supposed to train our model on the whole data set, and we can say that stochastic gradient descent in that like model is trained by using the mini batch of training at one side, like, or you can say like we are using the SGD. Then one cannot expect the training error to go down smoothly, right? Sorry guys. Yeah. So the point is that like if we are using the SGD, if we are using SGD, then one cannot expect the training error to go down smoothly. At the same time, you can say that the training error oscillate, but after some training steps, we can say that the training error has gone down. Also, the minima uh, achieved by using GD may vary from that achieved using the SGD. It is observed that the minima achieved by using SGD are close to GD but not the same. Now come to the next question. That is the most important, guys. Central limit theorem. What is the central limit theorem? So central limit theorem is nothing but the theorem that is related to finding the. It is similar to sampling distribution of sample means tends to towards a normal distribution. So we can say central limit theorem will be only applied when we have a normal distribution, and you can say that when we have like a sample size increasing, right? So you can say like population is like a distribution, like you can say normal distribution, say, and we can take some sample points from the distribution and calculate its mean. The distribution of those mean probably will follow the normal or Gaussian distribution, no matter from the distribution which have taken the same points. So you can say there is some certain condition of the size of the sample. Yes, if the size of the sample is greater than or equal to 230, then CLT will be hold. Otherwise, it is CLT will not hold. And the mean of the sample means approach the population. So that's completely fine. There are some advanced machine learning questions as well, which has been very important for all of you guys. So uh, let's start those questions as well. Uh, so like there is one more question is that like let's say we have to explain the principle of SPM, right? So it said that is not separable. A data set a data set that is not separable in different class in one plane may be a separable in another plane. This is exactly the idea behind the SVM. In this, a low dimensional data is mapped to a high dimensional data so that it becomes a separable in a different classes. A hyperplane is determined after mapping. You can say what a hyperplane. A hyperplane is determined after mapping the data into the higher dimension. Determined after mapping the data into the higher dimension, which can separate the data into the categories. After that, you can say SVM model can even learn nonlinear boundaries with the objective that there should be a much margin as possible between the category in which the data has been categorized. To perform this mapping, different types of kernel are used, like a radial basis kernel, Gaussian kernel, polynomial kernel, and many others. So there you can say like SVM is nothing but is Is they said that is not a separable in different classes. In one plane, maybe separable in another plane. So basically, we are discussing about the low dimensional data is mapped to high dimensional data, right? So I think everybody is clear till here. Any doubt till here, please let me know, right? I will appreciate it. If you're coming to the next question, what is the difference between k means and KNN? K means plus person. The only difference between the two is centralized. K means within the centroid initialize, because K means like this is the unsupervised learning, and unsupervised learning that we have unlabeled data, and we need to find if we have unlabeled data, we will go for centroid initialization. What is the drawback of this method? That random initialization leads to a non-optimized cluster due to maybe the slice of two cluster each other, right? So till here, I think everybody is getting. Now the question is that to overcome this kinds of problem, what can we do? We create such algorithm and we form the k plus k means plus plus. In those, we are trying to find the first centroid is selected randomly from the data points, right? And we select the subsequently centroid is based on their separation from the initial centroid. Yes, that's true. Uh, the most important point is that how to deal with this k plus plus algorithm. For those, the reason is that the probability of the point being selected as the next centroid is proportional to the square distance between the point and the closest centroid that has already been selected. This guarantees that centroids are evenly spread apart and lower the possibility of convergence to less than ideal cluster. This helps the algorithm reach the global minima instead of getting stuck at some local minima. Okay, so read more we can skip. Explain some measure of similarity which are generally used in machine learning. Okay, so what are the some measurement we use? Cosine similarity we use Euclidean or Manhattan distance. We use the Jaccard similarity. What is the cosine similarity? We know the range of cos theta is what, -1 to 1, right? So that's not a problem. And like, what is the one represent? One represent the two vector with a high similarity, and -1 represent the two vector with a completely two different approach. So if you're coming with the Euclidean one, Euclidean is nothing but the we are like a like a Instagram, like a Facebook, or like a like a Twitter, like a YouTube. So they are the channel they are using these kinds of algorithm like a Euclidean distance, because they have to pick such kind of customers who have a same pattern. So for that we use the K algorithm, and in KNN we use the included distance. So that's completely fine. So I hope everybody is getting. Jaccard similarity, it is also known as IOU, or intersection over union. It is widely used in the field of uh, it is widely used, you can say, in the field of object detection. Now the question is that how we use in object detection. So far so good. Like to like we need to evaluate it to understand the overlap between the predicted boundary box and the ground truth bounding box. So this is the something that we need to understand the relation between them. Okay, that's completely fine. Now come to the next question. What is the meaning of what happens to the mean mode when your data distribution is right skewed and left skewed? Okay. So coming to this point, we have in case of the left skewed distribution is also known as the positive skewed distribution. Mean is greater than the median, which is greater than the mode, right? But in case of the left skewed distribution, that is completely reverse. We can say in right skewed, what we say, mean should be greater than median and median should be greater than mode. But if you're considering to left skew, mode is greater than median is greater than mean, right? Yes, guys, we will try to finish in last in 5 to 10 minutes. We will try to summarize it, uh, and then we can continue it by tomorrow for sure. We'll try to summarize it as well. So we have something that mean should be greater than median, and median is greater than mode. Mode is greater than median is greater than mean. That is a case question of left skew. Now the next question is that better decision tree or random, which is more robust to apply. You can say decision tree and both are robust, but decision tree model is a symbol of multiple decision trees. So output of random forest model is an aggregate of multiple trees. So we can say that increase the result of chance of fitting get reduced. Hence we can say that random forest model are more robust to outliers. This is the one answer. Now the next question is that what is the difference between L1 and L2 regularization? What is their significance? It's L1 regularization, we can say lasso regularization, and we add the sum of absolute value, the weight of the model in the last factor. Till here, I don't think we have any doubt or any certain kinds of problem. So we can discuss. So L1 regularization waits for those features which are not at all important are penalty to zero. In turns, we obtain feature selection by using the L1 regularization technique. Okay. What about the L2 regulation? In L2 regulation, also known as the you can say ridge regulation, in which we add the square of the weight to the loss function. And you can say in both of these regulation method, weight are penalized, but there is subtle difference between the objective they help to achieve, right? And you can say in L2 regulation, the weight are not penalized to zero, but they are near to zero. For the irrelevant feature, it is often used to prevent overfitting by shrinking the weights towards zero, especially when there are many features and data is noisy. So you can say L1 and L2 regularization basically we use to uh, overfitting problem, to handle the overfitting problem. What is the radial basis function that we can skip because that is not type finding is very important. The smooth method you can skip, that is not important. How does score value good at matrix to okay, so there is some certain level ka question is there in which I believe that there is question. So I think that yes, right. Does the accuracy score always a good matrix to measure the performance of classification model? No, there are times when we train our model to an imbalanced data set. The accuracy score is not a good matrix to measure the performance of the model. In such case, we use the precision and recall to measure the performance of the classification model. And also you can say F1 score is another matrix that can be used to measure performance, but in the end, F1 score is also calculated using the precision and recall, as the F1 score is nothing but the harmonic mean of the precision and recall. That's true. Okay, so I think we can here finish till here, right? That's completely fine. Yes, that's completely fine. I believe that is completely fine. I don't think it's a problem, right? Yeah, that's a great deal. Yeah. So let's finish the session by here, and we will try to meet tomorrow again. We will try to join, and if you have any doubt, you can please let me know. You can mail me. Everybody know my mail, and you can message me to the LinkedIn, or like you can try to contact me as well. So you're all welcome. Okay. Thank you very much.